Have you ever had one of those moments where you're just uh, absolutely convinced you remembered a conversation perfectly, like every word, every gesture,
Oh, definitely.
only to have someone else who was right there recall it completely differently?
Mm-hmm.
Or maybe you've tried to piece together a childhood memory, and it feels like this hazy blend. Stories have been told, mixed with images you've just imagined.
Yeah, it happens all the time.
Yeah.
It really makes you pause and wonder, doesn't it?
It does. How reliable is our memory, truly? Is it this flawless recording device, like a high-definition video camera in our minds, just waiting for us to hit rewind?
Well, that's the million-dollar question, right? It gets right to the core of our personal truth, and it's far more complex than a simple yes or no. The latest science tells us that our memories aren't static recordings at all.
Really? Not like a file saved on a computer.
Not quite. Instead, they're dynamic, actively constructed experiences. Our brain is constantly working on them.
And that, my curious listener, is precisely what we're plunging into today on the Deep Dive. We're exploring the fascinating and often, well, counterintuitive world of human memory.
We'll unpack how our brains build, store, and retrieve our past experiences, why these intricate processes sometimes lead to some truly surprising distortions.
Yeah, those moments where you think, where did that come from?
Exactly, and we'll look at what cutting-edge neuroscience is revealing about this most personal of human faculties. We've pulled together insights from foundational theories right up to the latest brain imaging studies to give you a comprehensive picture.
Our mission for you is to demystify the complexities of memory. We want to show you why it's capable of incredible accuracy, yet also, quite surprisingly, prone to fabrication. It's a delicate balance.
Absolutely. We want you to walk away from this deep dive with a clearer understanding of how your own memory operates, and hopefully a newfound appreciation for how to navigate the vast ocean of information in your daily life, and even, your own recollections.
Let's dive in.
Let's do it.
So let's begin with what feels like the central puzzle. Is memory inherently true, false, or perhaps both? This question has really been at the heart of what's often called the recovered false memory debate.
Oh, a big debate.
It asks two critical things. Can traumatic events genuinely be forgotten for many years and then remembered? And are all memories, especially deeply emotional ones, susceptible to distortion?
Right. And our sources emphasize that the research we're exploring today doesn't really take a definitive side on this. It's not about picking winners.
Okay.
Instead, it clarifies that important events, even highly emotionally charged ones, can indeed be forgotten and later recalled under appropriate conditions. That part is possible.
Right. And conversely.
Conversely, memories, even for highly emotional and significant events, can be inaccurate in truly consequential ways. But, and this is equally important, they can also be remarkably accurate.
So it's not all errors.
Not at all. It's a deeply nuanced picture, not a simple black and white one. Understanding this nuance is absolutely crucial, especially when you think about fields like, say, legal and clinical practice.
Oh, absolutely.
Yeah, where the reliability of memory can have profound real-world implications affecting lives and legal outcomes. Getting it wrong there has serious consequences.
That makes perfect sense. So if our memory isn't just a perfect recording device like a VCR playing back a tape,
Yeah.
then what is remembering? Our sources define remembering as a subjective mental experience. It's something we construct and feel.
Exactly. And to truly understand remembering, it often helps to contrast it with forgetting. Forgetting happens for so many reasons.
Like what?
Well, it could be poor initial encoding of the information. Maybe we weren't paying enough attention in the first place. Or a failure to consolidate that memory to really lock it into a stable, long-term form.
Okay.
Or perhaps a lack of appropriate cues to retrieve it later, like trying to remember a name but not having the right context, the right trigger to bring it back.
Right, that feeling of it being on the tip of your tongue.
Precisely. It could also be due to interference from other information that gets associated with the same cues, kind of muddies the waters. And what's often overlooked is that all these factors are subject to motivational influences.
Motivational. How so?
Well, for instance, the encoding of traumatic events can be poor because of our natural avoidance strategies, like self-distraction or dissociation. We kind of tune out to protect ourselves.
Makes sense.
Similarly, cues that might trigger deeply uncomfortable memories can be deliberately avoided, or we might actively seek out a less disturbing interpretation of an event. When you consider this multitude of factors, all the incidental and deliberate ways we forget, it really isn't surprising how much of our past slips away.
That really reframes forgetting, doesn't it? Not just as a passive failure, but as an active, sometimes even motivated process. And it leads to another fascinating point. There are multiple forms of memory beyond just conscious recall.
Right.
The philosopher William James, way back in 1892, had this incredible insight. Nothing we ever do is, in strict scientific literalness, wiped out.
And modern theories, often called multiple memory system theories, truly echo this. They emphasize that memory manifests in so many ways that don't necessarily involve or even require conscious remembering.
So things we know or do without actively remembering, learning them.
Exactly. Think about simple habits, develop skills like riding a bike, implicit memories where past experiences influence your behavior without you consciously recalling those experiences.
Like seeing an ad and then feeling more positive about the product later, maybe?
Yeah, something like that. Or even priming, where exposure to one stimulus affects your response to another later on. Even your general knowledge of facts, what we call semantic memory, operates without needing you to recall when or where you learned that fact.
Right. I know Paris is the capital of France, but I have no idea when I learned that.
Precisely. And for example, individuals with amnesia can acquire new emotional responses to stimuli without consciously remembering why they have those feelings. Or, as we sometimes see in conditions like PTSD, vivid perceptual fragments of a traumatic event might unexpectedly be cued.
Like a sound or a smell.
Yeah, even if a coherent narrative account of the whole event is poorly integrated, these aren't truly forgotten, but they're not consciously remembered in the way we usually think about recalling an event.
Okay, so memory is much broader than just hitting play on a past event.
Right.
Let's get specific then. What exactly is a false memory? Our sources are quite clear here. They define errors of commission as false memories.
Right, remembering something that didn't happen or didn't happen that way.
While errors of omission are simply memory failures or forgetting.
Exactly. Commission errors, these distortions where we remember something that didn't happen or remember it incorrectly, have actually been studied for a very long time. This goes way back to early research on how language can influence visual perception or how we recall the implications of a story.
So it's not a new idea.
Not at all. But the term false memory itself became quite controversial, especially when applied to highly consequential autobiographical events like memories of trauma,
Right.
versus what might seem like more benign intrusions in a simple laboratory word test,
Yeah, because there's a huge difference between misremembering a word on a list and misremembering a significant, perhaps traumatic life event. The stakes are totally different.
Precisely. Huge difference. However, our sources argue that false memory isn't really a theoretical construct or an explanation for why it happens. It simply refers to the fact of a commission error.
Just describes the phenomenon.
Just describes it. The argument is, if it's appropriate to use the terms memory and forgetting in both laboratory and real-world contexts, then the term false memory applies across both as well. Many common terms like false recognition or source memory error, where you remember a piece of information but get its origin wrong, are conceptually equivalent.
Like thinking you read something in the news when actually a friend told you.
Exactly like that. The controversy often stems from concerns about overgeneralizing theoretical explanations from the lab, but the underlying mechanisms of memory distortion are still relevant to both benign lab errors and more impactful real-world ones.
That makes a lot of sense, cutting through the terminology to the core phenomenon. And speaking of core phenomena, a key theoretical tool for understanding how these errors happen is the source monitoring framework, often called SMF.
Ah, yes, the SMF, developed by Marcia Johnson and colleagues.
What's the core idea there?
The core idea of the SMF is quite brilliant, actually. It suggests our subjective sense of remembering isn't a direct readout of reality, but rather an attribution we make about a current mental experience.
An attribution, like assigning a cause.
Sort of, yeah. We make this attribution based on certain features or qualities that seem to have been linked together during a specific past event. It's almost like our brain is playing detective, trying to piece together where a mental experience originated. Is this something I saw, heard, just thought about, imagined?
So what kinds of features or qualities are we talking about here? What clues does the brain use?
Well, the framework suggests it's a mix of sensory, contextual, and internal qualities from that mental experience. We're talking about perceptual information like the colors you saw or the sounds you heard.
Sensory details.
Right. Contextual information such as spatial and temporal details, where and when something happened. Semantic concepts, the meaning of things. Our own emotions or those associated with the event, and even information about the cognitive operations we were engaged in, like whether we were actively imagining something or trying hard to retrieve it.
Wow, okay. So lots of different kinds of information.
Yeah, and there are also less specific qualities, like how familiar something feels or how recently it seems to have occurred. These qualities guide our judgments about the origin of a mental experience because, on average, different sources tend to differ along these dimensions.
Can you give an example?
Sure, like dreams are often more bizarre and less coherent, maybe more emotionally strange than real-life events. And perceived events might be associated with more self-centered spatial detail compared to things we only imagined. The brain picks up on these typical differences.
But if they're usually different, why do misattributions occur? Why do we get it wrong sometimes? If dreams are weird and reality isn't, shouldn't it be easy to tell them apart?
Well, that's the key. The problem arises because the distributions of qualities from different sources often overlap.
Overlap, meaning?
Meaning sometimes imagined events can feel quite perceptually rich, or real events might lack strong contextual detail, or maybe your emotional state when imagining something was really intense. This overlap can lead to misattributions, like confidently claiming you perceived something that you only vividly imagined.
So the lines get blurred.
Exactly. Our brain is essentially making its best guess based on the available evidence, and sometimes the evidence is ambiguous or even misleading. This is a crucial insight. Remembering is an inference our brain makes, not a perfect recording being played back.
So our brains are constantly making these attributions about where our mental experiences come from. How does that process work? Is it always a deep, systematic analysis, like consciously weighing the evidence?
Not always, no. Memory attributions are the result of a source monitoring process that accumulates evidence across these different features of mental experiences. But crucially, the weighting of this evidence is incredibly flexible.
Flexible how?
It changes depending on our past experience, the current task we're trying to achieve, and even our motivations. Our cognitive system can use quick, intuitive, heuristic assessments, like making a snap judgment based on how familiar something feels or how vivid it seems.
Like a gut feeling?
Kinda, yeah. Or it can engage in more effortful, systematic processes. That's where you might actively try to retrieve additional supporting information, check the internal consistency of a memory narrative, or evaluate its plausibility against your general knowledge of the world.
So it's a mix of quick guesses and careful checking.
Right. And this blend of heuristic and systematic processing helps us identify doubt about a memory. And that doubt, surprisingly, is extremely functional. It's like an internal alarm bell.
Doubt is functional. That sounds counterintuitive. We usually think of doubt as a bad thing.
But it's incredibly adaptive. Doubt is a signal. It can cue us to seek more information, maybe ask someone else, hey, do you remember it this way? Or to corroborate details with external evidence. Or simply to reserve judgment, hold off on being certain. Or even to decide that it's okay to live with ambiguity.
So it encourages critical thinking about our own minds.
Precisely. It encourages us to be more critical in a good way. It prevents us from jumping to conclusions based on potentially flawed internal signals.
And it's not just an internal process happening in a vacuum, right? Social context also profoundly influences what we remember and how we evaluate those memories.
Oh, massively. Think about it. Imagine someone testifying in court about what did happen. Their goal, their agenda is accuracy. So they're typically driven to focus intently on specific perceptual and temporal details. What did the person look like? Exactly where were they standing? Precisely when did this occur?
High stakes for accuracy.
Very high. Now compare that to someone in therapy who's encouraged to consider possible scenarios in which they could have encountered a person, perhaps to explore a feeling or understand a pattern related to past trauma.
A different goal entirely.
And completely different. They might focus less on specific perceptual and temporal details and more on general familiarity, emotional resonance, or the overall theme. Even if the initial encoded details were the same in both cases, the extent to which different features are weighted and whether heuristic or more systematic processing is applied will likely differ significantly based on that currently activated agenda and the social context of the retrieval.
So the situation you're in when you remember actually changes how you remember.
It absolutely shapes the retrieval process and the resulting memory experience. It's a powerful demonstration of how our goals and our environment shape our recall.
That's a truly powerful point about how our current goals and even the people around us can shape the very fabric of what we remember. And these lab findings aren't just theoretical. They really do generalize to everyday life, don't they?
Mm.
We see that imagined words, pictures, or even complex events can be misattributed to actual perception.
Yes, and that leads to another crucial insight, how emotion influences our source memory. Generally, if you only consider item memory just remembering the thing itself, emotional items are often recalled and recognized better than neutral ones. Emotion seems to make things stick.
The flashbulb memory idea, sort of?
Sort of, yeah, although even those aren't perfectly accurate. But the effect of emotion on source memory on remembering where something came from is far more complex.
How so?
Emotion can be a very compelling feature in making source attributions. It can foster a greater sense of recollection or confidence, even when it's not actually associated with greater accuracy for the source details.
So it feels more real, even if the where or who is wrong.
Exactly. For example, if you focus intently on your own emotional response to what two speakers are saying, maybe one makes you angry, one makes you happy, you might increase your ability to recognize later that they spoke, but paradoxically decrease your ability to remember who said what. Your focus on the internal feeling overrides the external source detail.
Wow.
So while emotion can enhance the vividness of a memory, that vividness doesn't always guarantee accuracy regarding its true origin. It makes you wonder, doesn't it? If a memory feels incredibly vivid and intense due to emotion, how do we know if it's truly accurate about the source?
That's a lot to consider. Okay, we've talked about what happens with memory distortions, the phenomenology of it. But now for the really exciting part. How does the brain actually do it? This is where cognitive neuroscience and techniques like fMRI, functional magnetic resonance imaging, really come in,
Right, bridging the gap from behavior to brain.
helping us bridge those behavioral observations with the actual neural activity happening in our brains. It's like watching the brain in action.
This is truly where we dive into the brain's architecture. The medial temporal lobes, or MTL, and especially a structure nestled deep inside called the hippocampus, have long been recognized as absolutely critical for memory.
The hippocampus, yeah, you hear about that a lot with memory.
You do! Damage to these areas can lead to profound amnesia, a severe loss of memory, particularly for new events.
So they're kind of the central hub for forming new memories, especially episodic memories.
For episodic memory, yes, remembering specific events and experiences, they're crucial. Functional brain imaging studies, like fMRI, show that there's greater hippocampal activity when we try to bind different pieces of information together.
Bind them together like linking.
Like associating a person with a particular house, or an object with its unique location, or a word with the voice that said it, compared to just encoding individual items separately. This memory binding is a key function of the hippocampus.
And it's fascinating how that greater hippocampal activity during encoding, when you first learn something, is directly linked to better source memory later, not just remembering the item itself.
That's right. Studies have shown that stronger activity in the hippocampus when information is first being learned predicts more accurate recall of the source of that information later on. Where did I learn this? Who told me?
Okay.
This activity seems to be specifically about encoding those crucial source-specifying features, the context, the perceptual details that help us differentiate memories and avoid false recognition of similar related information later.
And does it light up during retrieval too?
It does. When we're remembering, hippocampal activity is higher when we correctly recall the source, when we remember which two items went together in a pair, and when we give a remember response, meaning we recall rich episodic detail, versus just a no response, which is merely a feeling of familiarity without specific details.
So remember versus know has a neural signature.
It seems to. This activity even correlates with how many details we rate our autobiographical memories as having. More detail recalled, often more hippocampal activity.
So it's not just about forming the memory, but also connecting it to its origins and all its sensory richness.
Yeah.
Are there other parts of the MTL involved beyond the hippocampus?
Yes, definitely. Other MTL regions also play important roles. The parahynal cortex, for example, seems particularly important for item or object memory, often associated with that sense of familiarity we just mentioned, the know feeling. And the parahippocampal cortex seems particularly important for memory, for spatial context, helping us remember where things happened. So different parts handle slightly different aspects of the memory.
Beyond these core memory structures in the MTL, our brains also have these incredibly specialized sensory libraries, right? What scientists call cortical representational areas.
Indeed. Our brains have dedicated processing zones for different types of information. It's quite amazing, really. We have regions particularly active for faces, the fusiform face area, or FFA.
Right.
Other areas for places like the parahippocampal place area, PPA, still others for objects like the lateral occipital complex, LOC, and even for visually presented words, the visual word form area. There are specialized areas for colors, sounds, and even for concepts related to the self, often involving the medial prefrontal cortex. It's like a highly organized library system.
What's truly intriguing here, and this connects back to the source monitoring idea, is that the same brain regions involved in perceiving a type of information are also active when we're just thinking about it or imagining it.
This is a profound insight, yeah. For example, seeing a scene again and just mentally refreshing a scene, meaning you're actively thinking about it, bringing it to mind without it being physically present, activate a very similar network of areas in the posterior scene selective cortex.
So thinking about seeing something uses the same brain machinery as actually seeing it.
To a large extent, yes. This overlap provides a powerful neural basis for the source monitoring framework we discussed earlier. It helps explain how our internal thoughts and imaginings can become confused with external reality, simply because they activate similar neural pathways. The brain signal looks similar from the inside.
And this overlap, then, is a key mechanism for how perceptual detail fuels false memories, right? A vivid imagination can make something feel real, neuronally speaking, even if it didn't actually happen.
Precisely. Studies using fMRI have shown that activity in a brain area called the precuneus, which is often active during episodic memory retrieval and imagery, is greater for imagined items that participants later incorrectly called seen.
Ah, so the brain activity matched what they thought happened, not what actually happened.
Exactly. This strongly suggests that the sheer amount of activated perceptual information in our mental representations, even if it's purely imagined, contributes significantly to the subjective feeling of remembering, which can unfortunately be very misleading about the true origin of that memory.
And that fits with the behavioral finding that false memories tend to have less detail, right?
It does. Consistent with behavioral findings, false memories generally tend to have less fine-grained detail than true memories. Neuroimaging studies support this, often showing less activity for false memories in brain areas involved in processing specific perceptual detail, like the primary visual cortex for seen pictures versus imagined ones that are falsely recalled as seen. The signal is just not quite as rich.
So we can be tricked by vivid internal experiences. What about when we're given a lot of related information? Can that lead to a kind of semantic overload that makes us more prone to false memories?
Absolutely. This is a classic finding. If strong semantic cues are available, like in that famous lab paradigm using a list of words all related to sleep, words like night, dream, bed, tired, but the word sleep itself isn't presented,
Okay.
people are much more likely to rely on that strong semantic theme, the overall meaning, rather than the specific perceptual details of what they actually heard or saw. This leads to really high rates of falsely recognizing the critical missing word sleep.
Because it just fits so well.
It fits perfectly with the theme. It's like our brain prioritizes the gist or the meaning over the exact sensory input in those situations. This illustrates a trade-off. Strong semantic activation can be helpful for understanding, but it can also override the subtle perceptual cues needed for accurate source memory.
That's a tangible link between the brain's processing of meaning and memory distortion. Fascinating. Now let's turn to the parietal cortex. This area seems to play a significant role as an integrator and maybe even a confidence gauge for our memories.
Indeed. There's growing interest, especially in the last decade or so, in regions of the lateral parietal cortex, particularly areas below what's called the inferior parietal sulcus. Activity in these areas is consistently linked to the number of features remembered, the vividness of a memory, and that subjective experience of recollection, that feeling of truly reliving an event in your mind.
That raises an interesting question. If it's so involved in vividness and recollection, does damage to the parietal cortex affect the accuracy of memory, or just the feeling?
Well, this is what's quite surprising here. Studies of patients with bilateral parietal lesions damage on both sides often don't show a significant deficit in source accuracy itself. They can still tell you where they learned something reasonably well.
Okay, so accuracy is okay.
But they do show reliably reduced confidence in their source judgments. They're less sure about their correct answers.
Huh. Less confident even when right.
Exactly. They also tend to report less detail in their autobiographical memories, even if what they recall is objectively correct. This suggests that the parietal lobes might be crucial for integrating multiple features from different brain areas, contributing strongly to our subjective sense of remembering, that feeling of richness and certainty. Or perhaps they iteratively attend to different features, acting as an accumulator of evidence during source monitoring.
So it helps build the feeling of a strong memory.
That seems to be a key part of its role, yes. It contributes to the subjective quality, the confidence we place in the memory.
And then we have the frontal cortex, often called the prefrontal cortex or PFC. This seems to be the executive maestro of memory, pulling everything together strategically, the big boss.
It is absolutely vital for memory, acting as that top-down control system. Damage to the frontal cortex severely disrupts our strategic search of memory. It doesn't necessarily wipe out memories themselves, but it impairs our ability to access them effectively and monitor their accuracy. This causes greater deficits in complex recall or source memory than in simple recognition.
So recognizing something might be fine, but actively recalling when or where becomes hard.
Exactly. Notably, damage to certain areas within the prefrontal cortex, like the ventromedial prefrontal cortex, VMPFC, can result in profound source misattributions that are clinically known as confabulations.
Confabulations, we hear that term sometimes. What exactly does it mean?
These can range from relatively trivial filling in of missing but highly likely details, like someone assuming they had breakfast, because they usually do, to quite bizarre memories of impossible events, like someone genuinely believing they were a space pirate or lived on Mars, and recounting these memories with utter conviction.
Space pirate is a vivid example of just how far these distortions can go. That's incredible. And it's interesting how frontal areas develop relatively slowly in children and also show disproportionate neuropathology like damage or shrinkage in older adults.
Yes, and that seems to contribute to both groups' increased rates of false memories. It's a developmental and aging vulnerability. The control systems aren't fully developed early on, and they can be among the first to decline later in life.
So what are the specific jobs of the frontal cortex in memory?
It's involved in both encoding new memories and remembering old ones. During encoding, it helps us maintain mental agendas, like focusing on specific types of information. It refreshes information in working memory, resists distraction, and directs attention to specific features, essentially supporting the hippocampus in binding information together effectively.
Setting things up for good storage.
Right. And then during remembering, it's crucial for self-initiated retrieval cues, like actively trying to think of things that happened last Tuesday. It helps us assess the plausibility of retrieved memories. Does this make sense? And it's involved in generating or comparing alternative memories. It truly acts as the conductor orchestrating the memory orchestra, providing top-down control, strategy, and monitoring.
And different parts do different things.
Yeah, there's definitely specialization. The ventrolateral PFC, VLPFC, is active during encoding linked to subsequent memory and source memory, involved in semantic processing, selection, and rehearsal. The dorsolateral PFC, DLPFC, is more active for relational encoding and structuring information. And both VLPFC and DLPFC can actually modulate hippocampal activity, influencing what information gets prioritized and remembered. The very front part, the anterior PFC, seems involved in setting the overall agenda for what kind of source information we're currently looking for.
And it's linked to self-memory, too.
Yes. Anterior and medial PFC regions are active in self-referential tasks, like thinking about your own traits or aspirations, and in source decisions involving the self, like, did I say that or just think it?
Mm-hmm.
Interestingly, patients with schizophrenia often show deficits in this area during source monitoring of self-generated information, which might relate to symptoms like delusions or hallucinations.
Wow, okay. So the PFC is doing a ton of regulatory work. Moving to another crucial brain region, we have the amygdala, often associated with emotion. How does it interact with memory, and can our feelings sometimes fool us?
The amygdala, which is located within the medial temporal lobe, quite close to the hippocampus actually, is deeply involved in processing emotion. We know that damage to it, for instance, eliminates the memory advantage usually seen for emotional items over neutral ones. Emotional events just become ordinary memories without that amygdala boost.
So it flags things as important because they're emotional.
Essentially, yes. During encoding, greater amygdala activity for emotional items correlates strongly with later better memory for those specific emotional items. It's like a tag saying, pay attention, remember this. The amygdala can also modulate activity in other memory regions like the hippocampus and even the PFC, effectively boosting memory processing for emotionally charged content.
Does it matter if it's good or bad emotion?
Generally, the memory advantage applies to both positive and negative emotions. It seems to respond more to emotional intensity or arousal than to the specific valence, whether it's good or bad. Stronger emotion, stronger boost, typically.
So emotion can make memories stronger, more vivid, But can it also lead to distortion? Can that feeling fool us?
Absolutely. This goes back to the source monitoring framework. It suggests that emotion itself can be a very compelling feature that contributes to that subjective sense of remembering. It makes a memory feel more real, more salient.
Right.
What's often observed, both behaviorally and in brain imaging, is that the subjective experience of vividness or confidence, and even amygdala activity itself, can be greater for emotional items even when accuracy for the details is not higher.
So it feels stronger, but isn't necessarily more accurate.
Exactly. This raises that important question again. If a memory feels incredibly vivid and intense due to emotion, how do we truly know if it's accurate, especially regarding the source or context? The feeling can be misleading.
That's a critical point for real-world scenarios. Do we see this in cases of trauma, for instance, like with PTSD?
Yes. Consider a fascinating study on individuals with PTSD after the 9/11 attacks. 10 months after the attacks, compared to control participants, these individuals tended to remember their emotional response during the event as having been greater than what they had actually reported experiencing closer to the time, about 9 months earlier.
Their memory of the emotion got stronger over time.
It seemed to inflate, yeah. This could potentially be due to a selective rehearsal of the most intense aspects of the emotional experience over those months, effectively inflating their average memory of their emotional response. They remember the peaks more than the baseline.
And what about sustained stress, not just the acute emotion of an event? Does chronic stress affect memory?
It does, and often negatively for retrieval. Sustained stress, such as having chronically increased cortisol levels, can actually enhance the initial encoding of emotional information, making those stressful memories stick. But it tends to disrupt retrieval later on. It also seems to be associated with impaired function in the prefrontal cortex and hippocampus, those key memory control and binding regions.
So stress locks it in, but makes it harder to recall accurately or control.
That seems to be the pattern. Military training studies, for example, show that performing tests under high stress can lead to poorer memory accuracy and an increase in memory intrusions or errors. So while a burst of emotion might initially stamp in a memory, prolonged stress can compromise the very systems responsible for its accurate storage, regulation, and retrieval.
All this understanding of the amygdala and emotion has led to some pretty profound discussions about intentionally altering memories, right? This is where the ethical frontiers really open up. It's not just science fiction anymore.
It absolutely has. We're learning about the mechanisms. For example, drugs like propranolol, which is a type of beta blocker commonly used for high blood pressure, can reduce the amygdala's response to emotional expressions. Studies show it can also decrease the physiological startle response to previously fear-conditioned items.
Like reducing the fear reaction.
Exactly. And crucially, it seems to do this without disrupting explicit memory for the event itself. You still remember what happened, but the emotional charge might be lessened.
Wow.
This raises the striking possibility of using drugs to modify dysfunctional emotional responses, perhaps in populations suffering from PTSD, to sort of dampen the sting of traumatic memories.
But that sounds ethically complicated.
Extremely. This possibility has quite naturally sparked a new bioethics controversy. Is it wrong to erase the sting of bad memories? Is it right to pharmacologically change memories, even if the intent is therapeutic? This debate itself fundamentally underscores the scientific understanding we've been discussing that memories are not fixed, but reflect a dynamic origami of past, present, and future.
A dynamic origami. I like that metaphor.
They are constantly being reshaped, reconstructed, reinterpreted, and now we are learning how we might be able to intentionally influence that process.
That's a truly profound thought. Okay, moving from that, let's delve into memory in motion. How memories consolidate, reconsolidate, and the crucial role sleep plays in all of this. It's like the brain's internal maintenance crew, working behind the scenes.
Absolutely. Memory encoding, the initial learning happens rapidly, in milliseconds or seconds, but its long-term maintenance requires continuous processes that can go on for hours, days, weeks, even years. These are collectively called memory consolidation.
So it's not just about simple storage, like saving a file.
No, it's much more active than that. It's about converting an initial, often unstable or fragile memory trace into a more stable, robust, and effective form that can be accessed later.
So it's not a single quick event then, not just hitting save.
The traditional view of consolidation as just a single rapid stabilization process has definitely evolved. It's now understood to be a series of processes over different timescales. This includes stabilization, making memories resistant to interference from new learning,
Okay.
enhancement, improving performance on a task, like getting better at a skill, independent of any further practice.
Just getting better over time.
Yeah, seemingly passively. And integration, fitting new memories into existing knowledge networks in the brain. This integration is thought to be what eventually allows declarative memories, like facts or events, to be recalled even without direct hippocampal involvement, relying more on cortical networks.
And these consolidation processes, they just happen automatically.
Yes. Importantly, these are largely automatic processes, occurring entirely outside of our awareness or conscious intent. You don't have to try to consolidate your memories, your brain just does it.
Is there a reason it takes so long? Why not just instantly stabilize everything?
That's a great question. It's thought that this extended consolidation period isn't just a quirk of evolution. It might actually serve a functional role. It allows for a potential period of functional correction.
Functional correction.
Yeah, a chance to potentially refine or even prune inadvertently or imprecisely formed memories before they are fully stabilized and integrated into your long-term knowledge base. It's like a built-in quality control stage, maybe weeding out unimportant details or correcting initial misinterpretations before they become permanent fixtures.
So where does sleep fit into this complex picture? It seems like sleep-dependent memory consolidation is a critical piece, like the brain's night shift doing the heavy lifting.
You got it. Over the last decade or maybe two, a significant body of evidence has shown that sleep plays an absolutely critical role in this offline processing of memories. It's often referred to as sleep-dependent memory consolidation.
So sleep isn't just passive resting for the brain.
Far from it. The brain is incredibly active during sleep, actively working to solidify what we've learned and experienced during the day.
And different sleep stages contribute differently. It's not all the same.
That's right. Specific sleep stages appear to be critical for different memory types. Non-REM sleep, especially the deeper stages like stage 2 with its sleep spindles, and slow-wave sleep, SWS, is strongly linked to the stabilization and enhancement of procedural motor memories, like learning a finger-tapping sequence on a keyboard or a new sports skill.
Okay, motor skills.
And also for declarative memories, things like remembering facts or word pair associates. Early night sleep, which is naturally rich in that deep slow-wave sleep, seems particularly beneficial for strengthening these types of memories.
And REM sleep, the dream stage.
REM sleep, on the other hand, seems to be more associated with the consolidation of certain types of perceptual skills, like improving your ability to detect subtle visual patterns or textures, and maybe more complex emotional processing, too. So different sleep stages are like specialized processing units for different kinds of information learned during wakefulness.
It can even depend on whether you know you learned something.
Yeah, the sleep dependency can be surprisingly subtle and interact with awareness. For instance, in a classic task called the serial reaction time, SRT task, where people learn a sequence without realizing it, if participants become aware of the hidden pattern, their performance improvement seems to really benefit specifically from sleep. If they remain unaware of the pattern, improvement can happen during both wake and sleep. This suggests that explicit knowledge, the stuff you know, might be particularly sleep-enhanced, while implicit knowledge might benefit from consolidation processes that occur in both states.
So we can actually watch memories reorganize through neuroimaging, right? How does the brain replay these experiences during sleep? That sounds amazing.
It's truly remarkable. Brain imaging studies using techniques like fMRI or PET scans have shown that patterns of brain activity that were active during daytime learning, whether it's learning motor tasks, navigating a virtual maze, or even just learning new vocabulary, actually reappear or are replayed during subsequent sleep.
Replayed, like running the tape again.
In a sense, yes. These replays occur in both REM and non-REM sleep stages. And what's more, the extent of this replay, how much that learning pattern reactivates during sleep, often correlates directly with the amount of learning that occurred during the day or the subsequent performance improvement.
More replay, better memory.
It strongly suggests that sleep involves active processing and potential refinement of the neural connections, the synapses that underlie that learning, effectively solidifying what was learned. And it's not just simple replay or strengthening. There's evidence of large-scale reorganization happening, too.
Reorganization, how so?
Studies comparing brain activity before and after a night of sleep show profound shifts in the networks involved. For a finger-tapping motor skill task, for example, sleep leads to increased activity in brain areas responsible for motor control, like the cerebellum and primary motor cortex, and also in memory structures like the medial prefrontal lobe and hippocampus changes that presumably support more precise, faster, and more automatic movements.
Thus strengthening the core network.
Yes, but simultaneously, there's often decreased activity in other areas, like parts of the parietal cortex. This might reflect a reduced need for conscious spatial monitoring or effortful attention as the task becomes more automatic and ingrained. And sometimes decreased activity in parts of the limbic system too, perhaps suggesting a reduced emotional burden or anxiety associated with performing the task after consolidation.
So sleep doesn't just strengthen memories. It reorganizes them for optimal performance and efficiency, making them more fluid and accessible, maybe less effortful.
That's exactly the idea. It optimizes the neural representation. Similar reorganization happens for sensory skills too, with sleep leading to greater activity in relevant visual processing streams, improving identification of stimulus features, and again, sometimes a reduced emotional or attentional load.
And the cost of not sleeping.
Well, crucially, studies consistently demonstrate that sleep deprivation significantly interferes with this entire latent process of plasticity and consolidation. It disrupts both the behavioral improvements you'd normally see and the underlying neural mechanisms, the replay, the reorganization that support it. Skimping on sleep really does hinder learning and memory consolidation.
That's incredible. Sleep essentially optimizes our memories at a network level. And what about at the microscopic level? What's happening in the brain's cells and chemicals during sleep that helps memory?
Yeah, researchers are digging into that too. At the electrophysiological level, throughout the sleep cycle, distinct brain rhythms occur that seem conducive to synaptic plasticity, strengthening the connections between neurons. For example, sleep spindles, those bursts of activity during NREM stage 2 sleep, can provide patterns of input that resemble those known experimentally to induce long-term synaptic potentiation, LTP, a key cellular mechanism of memory formation.
So the brain waves themselves might be strengthening connections.
It looks that way. Theta waves in the hippocampus during REM sleep are also known to facilitate LTP. And other events like pontogeniculo-occipital PGO waves during REM, which have been linked to learning and fear conditioning, can also influence synaptic plasticity. At the cellular level, studies in animals show that sleep can actively enhance experience-dependent synaptic changes.
Enhance them how?
For instance, in studies of the developing visual system, a period of sleep following visual experience significantly amplified the structural changes at synapses compared to an equivalent period of wakefulness or darkness. Conversely, REM sleep deprivation can disrupt this normal developmental plasticity. It suggests sleep provides a necessary state for these cellular modifications to properly occur or stabilize.
And even deeper, at the molecular level, genes.
Yes. At the molecular level, blocking protein synthesis during REM sleep can prevent the behavioral improvements normally seen after learning, suggesting that building new proteins is crucial for sleep-dependent consolidation. What's even more striking is that research has identified around 100 genes that are specifically upregulated, meaning they become more active just during sleep in the brain, even without prior specific learning.
Genes that turn on only when we sleep.
Seems so. And when learning does occur beforehand, specific immediate early genes that are known markers for neuronal plasticity, like one called ZIF268, are found to be upregulated during subsequent REM sleep, particularly in brain areas involved in the learning. This provides direct molecular evidence for increased neuronal plasticity and gene expression during sleep that supports the consolidation of waking experiences.
So sleep truly facilitates memory consolidation at every level, from large-scale brain networks down to individual synapses, and even the genetic activity within neurons. It's not just downtime.
Definitely not just downtime. It's critical processing time.
Okay, so sleep helps lock memories in. This brings us to a truly fascinating and maybe somewhat unsettling concept related to memory stability: memory reconsolidation. You describe memory as a dynamic origami, and this seems key to that idea. It's essentially the brain's rewritable drive.
That's a good analogy. Yes, the idea is that once a memory is consolidated and stabilized, it's not necessarily set in stone forever. When a previously stabilized memory is reactivated, brought back into conscious awareness through recall or rehearsal, even briefly, maybe just 30 seconds to 10 minutes.
Just thinking about it again.
It can become destabilized and return temporarily to a labile or changeable state, similar to how it was right after initial learning, before consolidation.
So it's like opening a saved file on a computer and then being able to edit it before saving it again. The act of opening makes it vulnerable.
Exactly. That's the core idea. This destabilized state seems to last for a limited time, maybe around 5 to 6 hours based on animal studies and some human research. This is the critical reconsolidation window.
And what happens during that window?
During this window, the memory needs to be restabilized through a process called reconsolidation, which likely involves similar cellular and molecular mechanisms as the initial consolidation, like protein synthesis. If this reconsolidation process is blocked or disrupted during that critical window,
Say with a drug or maybe some kind of interference?
precisely. If reconsolidation is blocked, the reactivated memory trace can degrade relatively quickly, becoming weaker, less accessible, or perhaps even altered over time. It doesn't get saved properly.
This raises an important question. If we can block reconsolidation, what are the implications, especially for things like fear or trauma memories? This is where the potential therapeutic application becomes profoundly interesting, right?
Absolutely. For conditions like PTSD or phobias or even addiction, which involve very strong, often intrusive, maladaptive memories, the idea of blocking the reconsolidation of those specific problematic memories holds enormous theoretical promise.
How might that work?
Imagine reactivating a specific traumatic memory or a fear memory in a controlled clinical setting. Then, within that 5 to 6 hour reconsolidation window, administering a treatment, maybe a pharmacological agent like propranolol, or perhaps even a behavioral intervention that specifically blocks its reconsolidation. The hope is that this could selectively weaken the long-term maintenance or the emotional impact of that specific memory, potentially leading to rapid, targeted, and lasting relief.
Without erasing the memory entirely, but maybe reducing its power.
That's often the goal, yes. To reduce the maladaptive emotional or behavioral response associated with the memory, making it less disruptive. The therapeutic implications, if this can be safely and effectively translated to humans, are potentially profound for treating conditions rooted in problematic memories. It truly highlights just how dynamic and changeable our memories really are, not fixed archives.
Okay, now let's shift gears to something that's always been a bit mysterious, maybe even mystical when it comes to memory. Hypnosis. Is it a friend or foe to our recollections? Where does it fit in this picture?
Hypnosis. Yeah, it carries a lot of cultural baggage. Scientifically, it's generally characterized as an altered state of consciousness, typically induced by a procedure involving suggestions for relaxation, focused attention, and imaginative experiences. Key features include highly focused attention, reduced peripheral awareness, and an increased tendency to respond to suggestions made by the hypnotist.
So it's about suggestion and focus. Does it have real physiological effects?
It does. Hypnosis has been shown to affect the autonomic nervous system, ANS, the body's automatic control system. Generally, it tends to increase parasympathetic activity, the rest and digest system, and decrease sympathetic activity, the fight or flight system. This can influence things like heart rate variability and blood pressure, often shifting the body towards a more relaxed physiological state.
Okay, so it can induce relaxation. Now, historically, hypnosis has been suggested, sometimes quite strongly, as a powerful tool to enhance memory, what's called hypermnesia, and facilitate recall. You hear about hypnotic regression, this idea of taking someone back in time to recall repressed traumatic memories from early life. The underlying theory, often from a psychoanalytic perspective, was that bringing these unconscious memories to awareness could lead to rationalization, catharsis, and mental health benefits.
Right, that was a prominent idea for a while. However, this practice and the use of hypnosis for memory recovery in general has been heavily criticized, especially since the memory wars of the 1980s and 90s.
Criticized why? What are the big concerns?
Here's where it gets really tricky. The major concern is that hypnosis, particularly when used with suggestive techniques, has been accused of inducing false memories or distorting existing ones, rather than genuinely recovering accurate, forgotten memories.
So it might create memories instead of finding them.
That's the serious risk. This has severe implications, particularly in therapy, where a patient might come to genuinely believe in past abuses or traumatic events that never actually occurred, based on experiences or memories generated during hypnosis. And the legal implications are enormous too, especially in cases involving alleged past trauma where testimony might be influenced by hypnotically retrieved memories.
What about in forensic settings, like helping eyewitnesses?
Even there, where hypnosis has sometimes been used to help eyewitnesses or crime victims recall details, it has faced considerable criticism and scrutiny due to the high risk of suggestion contaminating the witness's memory. Many jurisdictions now restrict or disallow hypnotically refreshed testimony for this very reason.
And is the research clear on this hypermnesia claim? Does hypnosis actually make memories more accurate or just make people report more things, accurate or not?
The research on memory enhancement under hypnosis or hypermnesia is really quite conflicted and debated. While some older studies reported improvements in the quantity of recall, people might report more details under hypnosis.
Okay.
Many researchers argue that any observed enhancement is more likely due to factors like repeated retrieval efforts by participants. They're just trying harder to remember because they're in a special context, or changes in reporting criteria, they become more willing to report uncertain or fragmentary details. There's little convincing evidence that hypnosis uniquely improves the accuracy of recall, compared to, say, just encouraging someone to try remembering again in a normal waking state.
So it might lead to more stuff being recalled, but not necessarily more correct stuff. And if it's not reliably enhancing true memories, how exactly can hypnosis lead to the formation of false ones? It seems to be particularly potent for distortion, based on the controversies.
It absolutely can be. Hypnotic regression techniques are particularly controversial because they can unintentionally lead to false memory recall through several mechanisms we've already touched upon. First, imagery, which is a fundamental component of most hypnotic inductions and suggestions, can negatively affect memory recall by facilitating false memory formation.
How does imagery do that?
As we discussed with source monitoring, vividly imagining an event activates similar brain areas as experiencing it. This makes it easier to later misattribute the imagined details to a real perception. Studies suggest that realistic imagery, which hypnosis often encourages, is particularly prone to producing these false memories compared to more abstract or metaphorical imagery.
And that ties back directly to what we discussed with the source monitoring framework, where those imagined details can be misattributed to real events because they share similar perceptual or cognitive qualities in our brain.
Exactly. That's the source misattribution effect. In action, a person attributes an internally generated imagined event to an external, real-life perception, making a memory that was constructed inside feel like it came from outside.
What else contributes under hypnosis?
Well, on top of simple misattribution, hypnotic suggestions can also directly inflate a person's confidence in the accuracy of their memories, even if those memories are false. This is sometimes called imagery inflation. The authoritative context of hypnosis and the suggestion that recall will be enhanced can make someone feel unduly certain about the vivid mental experiences they have, powerfully rewriting their perception of their own past.
So they become more confident, even if they're wrong.
Yes, confidence and accuracy can become dangerously decoupled. The context of the hypnotic session itself and the patient's expectations about hypnosis revealing hidden truths can also influence memory recall, boosting confidence in the accuracy of retrieved autobiographical memories, particularly in individuals who are highly susceptible to hypnosis.
So is it the person's inherent hypnotizability, how susceptible they are to suggestion, that makes them prone to false memories? Or is it the hypnotic state or procedures themselves?
That's a debated point within the research community. While some studies suggest that high hypnotizability or traits like high suggestibility or dissociation might predispose individuals to forming false memories, both in and out of hypnosis, others offer opposing views. Some argue it's the specific suggestive techniques often employed within hypnosis, like guided imagery, leading questions, or explicit suggestions to recover memories, that are the primary culprits, regardless of an individual's inherent susceptibility. It's likely an interaction between the person, the procedure, and the context.
And emotional state matters too.
Yes, emotional distress, like high levels of anxiety, has also been found to potentially lead to more inaccurate memories being reported under hypnosis. And it's clear that hypnotic suggestions, whether intentional or unintentional on the part of the therapist, have been shown to modify memory recall. While some research suggests pre-hypnotic warnings about potential distortion or post-hypnotic suggestions to critically evaluate memories might help reduce false memory formation to some extent, their effectiveness is still debated and likely limited.
This all brings us to an interesting connection. How hypnosis, cardiovascular health, and cognitive function might be linked, perhaps in a more positive way. Our deep dive has already shown the crucial brain-heart interaction.
Indeed. We know cardiovascular health directly influences brain health and cognitive processes. Conditions like cardiovascular diseases, hypertension, etc. can impair blood flow to the brain, leading to cognitive decline, increased risk of dementia, and, as we mentioned, potentially even confabulations or other memory problems. A healthy heart supports a healthy brain, including its memory functions.
But hypnosis itself can have physiological benefits for the cardiovascular system, right? You mentioned the autonomic nervous system effects.
Yes, it can. As we noted, hypnosis can directly benefit the cardiovascular system, at least temporarily, by increasing parasympathetic activity, promoting relaxation, and decreasing sympathetic activity, reducing the stress response. This can help mitigate the acute cardiovascular reactivity to emotional distress, and, hypothetically, if practiced regularly, could contribute to better not cardiovascular health regulation, maybe reducing the risk or severity of conditions like hypertension.
And indirect benefits.
Beyond these direct physiological effects, hypnosis also seems to have potential indirect benefits for cardiovascular health through behavior change. It can be used as a tool to help people adopt healthier lifestyles, things like quitting smoking, reducing unhealthy snacking, increasing physical activity through hypnotic and post-hypnotic suggestions, using the power of suggestion to reinforce positive habits that ultimately benefit heart health.
What's truly fascinating here, connecting back to cognition, is that the relaxed state induced by hypnosis, which seems similar to what you experience in meditation and mindfulness practices, can actually improve certain cognitive functions, maybe including memory.
Yes, there's some evidence for that. The deep relaxation and focused attention cultivated during hypnosis might improve performance on tasks requiring sustained attention. And some studies suggest that this state might also facilitate episodic memory recall, perhaps simply by reducing mental clutter and anxiety that can interfere with retrieval. The reduced sympathetic nervous system activity during hypnosis also helps lessen emotional distress. And as we know, high distress and anxiety can negatively affect memory functions. When you're calm, your brain systems for memory likely work more efficiently.
Okay, so maybe a paradox here.
It seems like it. While the physiological state induced by hypnosis relaxation, focused attention might generally be beneficial for cognitive function and potentially memory retrieval by reducing stress, the specific techniques often used within hypnosis, like guided imagery aimed at enhancing detailed autobiographical recall, must be used with extreme caution.
Because of the distortion risk.
Exactly. The risk of memory distortion, confabulation, or confidence inflation, especially if the therapist unintentionally leads the patient with suggestive questions or imagery, remains significant. So, the general relaxation benefits might be positive, but specific memory enhancement applications are fraught with peril. The potential benefits for overall well-being might be there, but we have to be incredibly careful and ethically mindful when using it specifically to access or recover past memories.
So let's tie all these threads together now. We've talked about lab studies, brain mechanisms, hypnosis. How do these findings about memory distortion generalize to our everyday lives? It sounds like they're not just academic curiosities confined to the lab.
Oh, far from it. The real-world relevance is substantial. Memories for highly emotional public events, those flashbulb moments like the Challenger space shuttle explosion or the 9/11 terrorist attacks, consistently show evidence of real-world source misattributions and confidence levels that are often way out of line with actual accuracy, even decaying over time.
So people are confident but wrong about where they were or what they heard.
Very often, yes. People might confidently recall details that simply didn't happen, or remember hearing the news from a source different than where they actually first encountered it. And these errors can persist or even increase over time. And beyond public events, researchers have even successfully induced reasonably complex, sometimes emotionally significant, false autobiographical memories in laboratory settings.
Induce false memories of personal events. Like what?
Things like convincing participants they were lost in a shopping mall as a child, or that they spilled a punch bowl at a family wedding, or were taken to the hospital overnight for a minor issue, events that their parents confirmed never actually happened.
How do they induce these?
They use factors similar to those that work for simpler stimuli, like words and lists, encouraging vivid imagination and visualization of the suggested event, using repeated questioning over multiple sessions, which can increase familiarity and belief, and sometimes embedding the false event within real aspects of a person's life to make it seem more plausible. For example, showing someone a real class photo from their childhood while suggesting a related false event that supposedly happened at school can increase the likelihood of them developing a false memory for that event.
And individual susceptibility plays a role here too, in who is more likely to form these false autobiographical memories.
It seems to. Studies looking at induced autobiographical memories confirm that individual differences can predict susceptibility. People with high imagery ability, high hypnotizability or suggestibility scores, or perhaps certain dissociative tendencies, tend to show increased rates of accepting and developing these suggested false memories. This suggests a potential vulnerability in certain individuals that can be exploited, intentionally or unintentionally, by suggestive techniques or leading questions.
These findings naturally lead us directly into what's been termed the memory wars. particularly relevant and often contentious in clinical and legal practice.
Absolutely. These findings raise very serious concerns about the uncritical use of memory recovery practices, sometimes employed in clinical or therapeutic settings. These practices might include things like using repeated suggestive or leading questions about potential past trauma, employing guided imagery to visualize repressed events, encouraging patients to look at old photos while speculating about hidden meanings, the use of hypnosis, or even certain drugs purported to enhance recall, or therapists encouraging lax criteria for what counts as a memory, essentially telling a patient if it feels real, it must be real, or trust your feelings over logic.
And are these practices common?
Surveys of therapists have painted a concerning picture, although awareness might be slowly changing. For example, one survey back in 1995 in the US and UK found that about 25% of responding therapists believed recovering repressed memories was an important therapeutic goal and reported using 2 or more suggestive memory recovery techniques quite frequently. More recently, a 2007 Canadian survey found that a surprising 53% of responding social workers, psychologists, and psychiatrists believed hypnosis could reliably recover memories from as far back as birth. And on average, these professionals reported using 2 to 3 specific memory recovery techniques, including hypnosis, age regression, guided imagery, and imagination exercises.
So even relatively recently, a substantial proportion of therapists still seem to support or use potentially risky practices, despite the growing body of research highlighting the mechanisms of memory distortion.
That's what the survey data suggested, yes. It indicates a potential gap between scientific understanding and clinical practice in some quarters.
Now, it's critical to inject nuance here. The research also shows that not all recovered memories are false, right? We have to be careful not to dismiss every recovered memory, especially of trauma.
That's an absolutely crucial distinction to make. The research does not imply that all recovered memories, particularly those of genuine trauma like childhood sexual abuse, are necessarily false. In fact, studies have found that some spontaneously recovered memories of abuse memories that surface naturally without specific therapeutic suggestion are statistically more likely to be corroborated by independent evidence than memories recovered specifically as a consequence of suggestive therapeutic techniques.
So the way a memory is recovered matters.
It seems to matter significantly. Corroborating this, in laboratory tests assessing susceptibility to false memory for related words, like the sleep example, individuals who reported spontaneously recovered memories of abuse actually made fewer false memory intrusions for those related items compared to control groups. Whereas individuals who reported recovering memories during therapy sometimes showed increased susceptibility to such false memories in the lab.
Interesting.
This further highlights a potential interaction between individual differences, maybe in cognitive style or trauma history, and the influence of suggestive therapeutic practices. So, while therapist-led recovery using risky techniques can definitely be problematic and increase distortion risk, some truly forgotten traumatic memories do seem to resurface naturally and accurately for some individuals. It's complex.
And it's not just remembering that's an attribution or construction. Even forgetting can be seen as an attribution based on our current state. That's a fascinating inversion of what we typically think.
Yeah, it follows the same logic. Much like remembering is an attribution based on the qualities of current mental experience, the feeling or judgment that one has forgotten something is also an attribution based on our current mental state and context. Studies using a clever forgot it all along paradigm have explored this. They find, for example, that individuals who spontaneously recover traumatic memories may, paradoxically, be more dominated by their current context when judging their past memory states.
What does that mean?
It means that shifts in their internal or external context might actually provide them with greater protection against the cueing of previous retrieval experiences. This could lead them to have poor memory for the fact that they had recalled those events previously, leading to the feeling of having forgotten it all along until the recent recovery. It's about how accessible prior recall episodes are now. And relatedly, simply asking people to try and recall more events from their childhood can sometimes lead them to judge their overall memory for that period as poor, perhaps because the effort highlights how much they can't recall, influencing their global judgment.
So even our assessment of our own forgetting isn't straightforward.
Not at all. It's also an interpretation based on current experience and retrieval dynamics.
All of this points to some truly profound ethical frontiers, particularly when we think about what some are starting to call memory hacking and its broader societal implications. Let's revisit those profound ethical issues that arise from new scientific possibilities, like using drugs such as propranolol to reduce the emotional response associated with traumatic memories.
Right. This ability, even if limited now, to potentially change memories by dampening the emotional sting or perhaps influencing reconsolidation, opens up what some are already calling a new iteration of the memory wars debate, focused now on intervention rather than just recovery.
And it really forces us to confront the nature of memory itself.
It fundamentally underscores the scientific understanding we've built up throughout this deep dive. Memories are not fixed, immutable records stored like files. They are, as Johnson and Sherman put it, that dynamic origami of past, present, and future, constantly being reconstructed, reshaped by retrieval, influenced by our current state, goals, and even potentially by targeted interventions.
This raises an important, maybe even unsettling question for all of us. If our memories, which we often view as the very foundation of our identity, our personal history, our sense of self, can be influenced, altered, or even edited, what does this mean for our understanding of who we are?
It's a huge question. And looking to the future, could memory hacking, whether pharmacological or technological, become a tool used for manipulation? Could it become a form of cognitive weapon, altering perceptions of reality or history on a societal scale? The science is fascinating, but the personal, ethical, and societal implications are truly profound and demand careful consideration as our capabilities grow.
So after all that, we've taken quite a deep dive into the incredible and complex world of human memory today.
We certainly have.
We've learned that it's far from a perfect video recorder of our past. Instead, it's a dynamic, constructive process, constantly evolving, integrating new information, and sometimes creating surprisingly vivid distortions or illusions that can feel absolutely real.
And while memory generally functions remarkably well, it gets us through our days pretty effectively. Its inherent malleability means it can, under certain circumstances, produce mental experiences that feel undeniably real, vivid, and highly emotional, even if they're not accurate reflections of what truly happened. It's a testament to the brain's incredible flexibility, its adaptability, and also its occasional fallibility.
Understanding these mechanisms isn't just for neuroscientists or therapists or lawyers. For you, our listener, it offers a powerful lens through which to view your own recollections and the vast amount of information, the stories, the claims you encounter daily. It encourages, hopefully, a healthy skepticism, not cynicism, but critical evaluation and perhaps a deeper appreciation for the nuanced nature of truth, experience, and recollection. So what does this all mean for you, navigating your own mind and the world?
And perhaps the final thought to leave you with. If our memories are always evolving, always subject to revision and reinterpretation based on our present, what does it truly mean to know our past? And how might our very understanding of self continue to change as our scientific grasp of memory, this fundamental human faculty, continues to deepen? Something to think about the next time a memory feels absolutely undeniably real, or maybe just a little bit hazy.